Hello coders, welcome to my video. In this video, we'll see how calloc is better than a malloc. What are the things that is creating some crash or there is some problem in malloc that is accompanied by calloc, and where to use malloc and where to use calloc. So these all things we'll study in this session. So first of all, we'll see what are the ways we can initialize the memory through calloc. So first is we have an API use calloc. Then in malloc we only have one argument, but here we have two arguments. Okay, so for example, if I need to initialize three integer variables, so what I will do, I will do three and comma, then we have size of in, and we will do int star of ptr. So this will initialize three integer using calloc. While in malloc we generally do like this. So we have int star of ptr1, and then we use malloc, and we have 3 multiplied by size of int. Okay. So what is the difference between the two using malloc and calloc? So first difference is this arguments. So we have two arguments here and we only have one argument. Okay. That is returned by the malloc can contain garbage value, because malloc is only returning the memory. We are not flushing the data within that memory. But in case of calloc, the memory is zero initialized. So we don't need to flush out that memory before using to avoid errors. So let's see it. Okay, and let's see the both memory. Here we have PTR and next we have free PTR1. So to show that, what I will do, I will do printf percentage d. Okay, and this is for calloc. I mentioned calloc is equal to percentage d and comma, then we have star of ptr. Okay, so it will calculate the starting memory of these pointers, and here for malloc. So let's print it first. So I am getting some warning. Okay, so I need to give here include malloc.h and dash include stdlib.h, and let's, okay, now if I run this, so see, in calloc you are getting 0. So the memory is initialized as 0, but here we are getting some random values. So the memory is not cleaned up when using malloc. Okay, so I am using this f sanitize is equal to address to show the perks that is being suppressed. So in some cases you will get 0 if you want to use this. Okay, so one difference is this. So if I again go to this program, so how to make your malloc to work similar to calloc. So what I will do, I'll do the memset on that memory. Okay. So after flushing this memory, for example, if I have this PTR1, I'll map set this memory 3 into size of int. So three integers, they will flush out. Okay, if I compile it again, they are saying we should do string dot h here for memset and string dot h as here. And if I compile it again, no error is there, and now we are getting zero in both. So to make malloc behave as calloc, we should flush that memory using some external API like memset. And obviously, if you are using an extra API, you will consume more time. Okay. So your malloc plus memset for large allocations, it will take more time than only using calloc. So this is one of the reason that we are using calloc if we want to flush the memory of a structure, for example, where we are not initializing each and every member at one time. So if you are using malloc, you should clean or you should initialize the memory just after allocation of that memory. Okay. So we have some points here. So zero initialized memory. This is done. Prevent undefined behavior for uninitialized reads. Okay. So the undefined behavior is created when we are not fetching the memory of malloc and we are using the memory or dereferencing that memory. Then we have undefined behaviors. So prevent from crash for not allocation of the memory. Okay. So protection is there in calloc, but that is not there in malloc. Okay. So for example, if I take some size underscore v and n, and here what I will do, I'll take this size underscore max divided by size of int. Okay, and next what I will do, plus 1. Okay, and this size what I will do in calloc, I will put n here and here also I'll put n, and I'll remove this memset. So I don't need it because I am need to overflow this memory so that calloc and malloc won't allocate it. And then I'll print here the address of the pointer. So here what I will do, I'll do p, and here it's already p. So I'll compile this the overflow. So it's showing I need std int dot h for size underscore max. So I will std int dot h, and now it's showing argument type is a void star, so I need to typecast it. Okay, so here what I will typecast void star to ptr, and here void star ptr1 as well. And now let's try it again. Okay, now it's fine. So better I will remove this sanitize for suppressing the error, and now I'll do it again. So you see here, you will get a nil here. Okay, so as the memory is not been allocated in any of the case, so calloc is giving you null while malloc is giving you some address. So you don't even know whether malloc is being filled or not. When you are trying to access this memory, you will get a code hump. So now what we need to know where to use malloc and where to use calloc. So mostly when we are initializing the parameters, just after allocation, we can use malloc. But if we are talking about a large memory or, for example, if I have a structure, so let's take this case. I have a stuck client, and here what I have, for example, integer ID, then we have integer active. Okay, then I have char star name, and then I have int star of scores. So this is a simple structure, and I just remove these all things. Uh, what I will do, I will do malloc on this structure. So what I will do, struct line star c is equal to malloc. Then I have a size of struct client. Okay. Now I try to initialize it. C points to ID is equal to 5, for example. Then I have C points to active is equal to 1. Then I have C points to name is equal to str loop, creating the buffer and giving it embedded wipes over here. I close it. Then I'm not initializing the last this course over here. Okay, and if I try to access this, for example, C points to source, and inside what I will do C points to scores 0 is equal to 100, for example. And at last, I will free the name. C points to name, and last is free. C points to scores. So these are the pointers to some memory. So let's compile it. Okay, and so if you see here, you'll get a segmentation fault. So I'm getting here the segmentation fault. So I got this call stack, but it's showing here read memory access. So I still won't get the exact location where the error is occurring. So what I will do, I will use with debug symbols, compile this, and I again, if I run this, so I see here the segmentation fault. I'll get that 33 line number in main. Okay. So if I open the heap memory again and go to 33 line, so you see here I am getting this segmentation fault because I am initializing a value to this pointer that is not been allocated, but still it got passed from here. So it should be 0, but there is some value in this that makes him pass this if condition and go for allocation. Okay. So what I will do now, I will replace this calloc with a malloc with a calloc. So calloc, I have one comma size of the structure, and that's all. So this time, if I compile it again, and now I run it, I won't get any error. It means the value that is present in this C point to score is automatically get to zero or null, so that it won't pass and access that variable. So this is one of the error that got ignored sometime while dealing with a C program, and it's very difficult to address and debug that thing. So this is all about a few difference between a malloc and calloc. This is all about this video. See you in the next video. Thanks.